if we take, we'll start with power of 0. What's x plus 1 to the 0 power?
0.
Are we back up here?
Yeah.
Almost. Okay, so this is x plus 1. How about x plus 1 to the 0?
1.
1, good. That's just how a 0 exponent is defined. Anything raised to the 0 power is going to be 1. Okay, and then we know x plus 1 to the 1 is itself, or to the first. X plus 1 squared, how would we do that?
X squared plus 2x plus 1.
Good. So what was the process?
FOIL.
FOIL.
You multiply them.
Yeah, or distributive property. How? Okay, x plus 1 to the third. Now, we don't really want to multiply out x plus 1 times x plus 1, and then take that and multiply all of that times x plus 1 again. That takes a really long time. So there's a shortcut that we're going to discover. There's a pattern to this. So what can we observe about this pattern? What can we fill in? What would come next in the sequence?
1.
1. Very good. Okay, now the middle two terms are,
X
do we know?
squared. X.
There is an x squared term, good, and there's an x term. And the coefficients,
2.
is that going to be 2?
1. 3.
It's going to be 3. And you can discover that for yourself by multiplying it all out, right? But this is what you would get. And so, as Gonzalo was saying before, and this pattern continues, I'll just dump rate this for you, sneak preview. Okay, so it would be what, Alcron? Good. What?
1.
Last term?
1.
Okay, in the middle, it's going to be 4x to the what?
Third.
Third, good. 6x
7.
squared, and it's going to be guesses?
8.
4x.
4x, very good, symmetrical. So the pattern, if we look at the leading coefficient, it's always 1. If we look at the last term, it's always 1. Then here the middle term was 2, 3, 3, 4, 6, 4. Okay? We can continue, this is called Pascal's triangle. We can continue this. There's a relationship. Do you see it?
Yeah.
What is it? Do you know it?
It's 1, and you put 1 to the side, and you add them together.
1 to the 2 was a 3, the 1 to the 3 was a 3 is 3.
But where did this come from? Okay, during the time of the Islamic Empire, the first complex algebra book was created by Muhammad al-Khwarizmi. It was used to move numbers from one side of the equation to the other in an attempt to isolate a variable. As you see here, there's easy equations as this, where you just subtract 4, and you get 2x equals 4, you divide by 2, and you get x equals 2. Then there's also harder equations, like this, which is shown by a graph having y and x. And
Creation of the complex algebra book. The Arabic scholars created a number system called the Arabic number system. These numbers include 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. They also developed values such as the ones place, the tens place, the hundred place, and the thousand place. This allowed them to describe numbers such as 19, 119, and even 1019.
As a result of Arabic math innovations, we are able to create / innovate almost anything using math.
We also are able to do simple things like count to 1 to 1,000 or do simple math equations.